Good evening, everyone. I am Neha Kanda from CSC department, first year. My topic is about classical free electron theory. Classical free electron theory. Introduction about the topic. Classical free electron theory explains the electrical and thermal conductivity of metals. It models conduction electrons as a gas of free particles within a positively charged lattice. This theory provides a foundation for understanding metallic bonding and electrical properties. And this classical free electron theory, also known as Drude-Lagrange method, describes the behavior of electrons in metals. This theory provides a foundation for understanding metallic bonding and electrical properties. This theory emerged in the early 20th century, building on earlier atomic theories. Notable physicists, including Drude and Lagrange, contributed to its development. This theory was instrumental in bridging classical physics and early quantum mechanics. First, we know about the free electrons. What is free electrons? Electrons are free to move within the metal. In this figure, we observe the in metals. In between the metal ions, we have to observe the free electrons. Electrons in metals behave as a gas of non-interacting particles. Positive ions in the metal lattice are fixed in space, providing a background charge. Collisions between electrons and lattice ions are the primary mechanisms for resistance. Collision is required in between the metals. Ions in which each other. The kinetic theory of gases forms the basis of the mathematical treatment of electrons. Key equations include Ohm's law and the Drude model for conductivity. These equations help predict how electrons respond to electric fields and temperature changes. In this classical free electron theory, we observe the classical mechanics, the motion of electrons described using classical mechanics. In this between the free path of the electrons. The theory predicts that electrical conductivity is proportional to electron density. Higher temperature generally lead to increased resistance due to more frequent collisions. The model explains why metals are excellent conductors compared to insulators. In this, we observe the diagrammatic representation of conductor current flow in between the electron cloud. Field is towards the electron cloud of negative sign and the current flow within the right side towards the current. In this, we can make the electrical conductivity. The ability of a metal to conduct electricity is called electrical conductivity. When it comes to thermal conductivity, classical free electron theory also applies a thermal conductivity in metals. Electrons carry both charge, thermal energy contributing to heat transfer. The theory suggests that metals with high electrical conductivity also have high thermal conductivity. In this free electrons toward the field direction, we observe this in this diagram. The thermal conductivity is the thermal energy in between the metal ions. And limitations of the theory. The theory does not account for electron interactions or quantum effects. It fails to explain superconductivity and phenomena at very low temperatures. Modern theories such as band theory have emerged to address these limitations. And also we take the limitations quantum effects and over simpler electron to electron interactions. And comes to applications of the theory, the classical free electron theory is foundational in solid state physics and material science. Helps in understanding the behavior of conductors in electronic devices. The principles derived from the theory, they are used in designing materials for better conductivity. Take the applications like electrical conductivity and the thermal conductivity. In comparison with free electron theory, classical free electron theory describes behavior in a classical framework. Unlike quantum mechanics, quantum theory introduces wave particle quality and the wave particle duality, which explains electron behavior at atomic scales, while classical theory basic understanding quantum mechanics offers a more precise description. Finally, we comes to conclusion. Classical free electron theory remains a cornerstone in the study of electrical properties. It set the stage for further advancements in condensed matter physics. Despite its limitations, it continues to inform our understanding of metallic behavior. We observe the diagrammatic representation of free electrons, n type, holes, electrons, negative charge. N-type, the majority charge carries electrons, and the p-type, the majority charge carries holes. I think this topic is understandable to all. Thank you.